Welcome back at Evolutionary Psychology, a YouTube video channel about the power of evolutionary thinking. Animals and plants are not our main subject of discussion. People, politics and societies are. Inspiring, sometimes controversial, but always stretching your mind. Last time we met, we talked about cooperation as the essence of complex evolution. We finished with the four main building blocks of cooperation. These we find as well in biological world as in the domains of mimetics. In this episode, we dive deeper in the intriguing dynamics of cooperation. We will learn a lot about human behavior. But to recap, the golden four. The first was division of tasks. This leads to specialization, and it has as a side effect the neglecting of unused skills, and this leads to dependency. We already saw some examples from nature of these universal principles. Remember the parasol ant and the fly, our intestine bacteria and we ourselves. In fact, working together is everywhere in nature. Sometimes it benefits both, and these are the most sustainable forms. Sometimes it only benefits one of the participants, as for example with the cuckoo and the hedge sparrow. Let's focus on how these four principles have shaped the world of mankind. We know from archaeological investigation that division of labor emerges in the earliest dawn of mankind. John, for example, was very skilled in making spears, but he was mediocre at best when it came to hunting deer. Just the other way around for Peter. Deer hunting was his passion, and his skills on it surpassed that of all his fellow tribesmen. But making a spear wasn't fun for him, and the results were poor at best. So what happened? Sooner or later they discovered each other's problems and talents, and made an arrangement. If you make some excellent spear for me, I will provide you with some fine venison. Both benefited from this deal. They both got better in the task they already excelled in, because they could practice in it even more than they did before. Quality as well as quantity of their outputs grew, and with this the total amount of wealth of their community increased. But it had also another side. They further neglected their already poor skills. This made them more dependent on each other than ever before. Division of labor probably started within family groups, spilled over to members of the same tribe, but soon after that cooperation spread between different groups and tribes. We know this because craftily handed stones were found some hundreds to 1,000 miles away from their natural sites. So they were probably handed over from one group to the other, functioning as a kind of money, a prehistoric currency. These traits are known to diminish wars and conflicts. When John and Peter were self-sufficient, the well-being of the other had limited impact on their own life. So killing another was in a certain way no big deal. This all changed when division of labor emerged. The well-being of Peter was directly linked to the well-being of John, and vice versa. Although most people think the opposite, capitalism is a force for peace. Journalist Thomas Friedman conducted a very interesting experiment some years ago. He took a Dell computer and had it deassembled by some skilled engineers, and determined where the parts originated. It turned out more than 40 countries were involved. The next step was Friedman examining the economic and foreign policies of these countries, especially to each other, and to his surprise, he discovered one very prominent denominator. They didn't wage war against each other. Although there were tensions at moments, they always succeeded in solving them in a peaceful way. The traditional Christian morality tells us you have to sacrifice something for the well-being of others. This is a kind of zero-sum thinking. Your enjoyment is always the suffering of someone else. So, if you want to have another person to be more happy, you have to give some of your happiness away. And even a lot of non-Christians have this model in their head when it comes to creating a happy, affluent and just society. Throughout history, there have been thinkers pointing out the essential flaws in this way of reasoning. Maybe you have heard of the Dutch-born philosopher Bernard Mandeville. He speaks of private vices and public benefits. The idea being that if individuals pursue their very best self-interest, others will profit from this as well. The most well-known theorist of this idea is the economist Adam Smith. He called it the invisible hand, and it grew out to become the core mantra of capitalism. To quote Smith, "It is not from the benevolence of the butcher, the brewer, or the baker that we expect our dinner, but from their regard to their own interest." End of quote. This isn't a plea for no-holds-barred capitalism, as Smith wrote in the same book, where he talks about a system of progressive taxes. We will come back to this discussion on wealth and wealth creation in one of the coming videos. But here I want to mention that capitalism can be both a blessing and a curse. But studying the facts, the blessings outweigh the curses with an overwhelming margin. So always be skeptic when people want to flush capitalism down the drain. Most of the time they didn't study the bare facts. The importance of the division of labor, of specialization, of trade and of international cooperation cannot be overstated. Things like Brexit and trade wars are therefore among the most irrational phenomena of our modern times. Autarky or self-reliant isn't something we should strive for. Artist Thomas Thwaites demonstrated this in the most amusing way. He set himself to the task of building a toaster, all on his own, without the help of other people, specialists or modern tools and technology. First of all, he had to cheat. He used waste materials and second-hand parts of existing equipment. The project took hundreds of hours of work. And the end result? It functioned for about 12 seconds and then it collapsed in fire. End of project. So, don't be over-romantic about people in the past being able to do on their own all the things they needed for survival. That wasn't heaven, that was hell. Back to Smith and Mandeville. The biologist and fervent atheist Richard Dawkins can be seen as the modern heir of these great thinkers. In 1976, he wrote his famous book, The Selfish Gene. The central and very powerful idea of this book is that genes are selfish and that they do almost anything within their power to survive. And one of the cleverest things they can do is to cooperate with other genes and other organisms. Cooperation as the ultimate form of selfishness. Remember the bacteria in our intestines. Being cooperative gives a far greater payoff than being not cooperative, as syphilis and the pest bacteria did. Short-sighted egoism is stupid. Rational, long-time egoism is smart and wise. Wise in the sense that it benefits the larger system as well as it benefits yourself. Dawkins showed, just as Smith did, that out of something seemingly bad, something good can arise. The second important premise of Dawkins' book is that the level of genes is the essential level of analysis in evolution. Not the individual, not the family, not the group or herd, and certainly not the species as a whole. Every evolutionary model based on the idea that animals behave in a certain way for the well-being of the species can be discarded as pseudoscience. Things they do that benefits others or even other species always originated in being good for themselves in the first place. So cooperation is good, but cooperation always is accompanied by a dark side, a sinister facet of which I will tell you in advance. We will never get rid of it. This shadow is called deceit. Vampires really do exist. They are small bats living in South America. With their thousands they dwell in caves, hanging on the roofs and going out at night to hunt. Their prey consists of big animals, like deer, cows and pigs. Once a bat found one, and they hunt as individuals, he lands very silently behind the sleeping cow and stealthily crawls to the heel of the ignorant animal. The vampire has razor-sharp teeth and bites in the heel of the cow. Being the teeth so sharp and with saliva seducing toxics and anticoagulation substances in it, the cow hardly notices the bite of the little Dracula. The blood keeps dropping out, and the hungry bat licks it with delight, until its belly is full with nutritious blood. Then he flies back to his cave. Arriving home, he meets mates which had a successful hunt too, but there are always a substantial number of hunters coming home empty-handed, Hunting is difficult and success is never guaranteed. Bats are little animals and need a lot of food. When not eating for 72 hours, they will starve. So, one night with no food is to be survived. But finding several nights in a row no prey causes serious problems for these little bats. But they have found a very clever solution, and that is, they help one another. Bats with an empty stomach lick on the lips and cheeks of successful hunters, and they give up some of the blood for their hungry neighbors to feed on. This system works for both parties. Today you are successful and you give something of your spoils. The next day you come home empty-handed and you receive some food of the generous neighbors you helped out a few days earlier. A very clever welfare or insurance system, as the biologist Wilkinson described it, who observed and studied this phenomenon in great depth. You will give when possible and receive when necessary. But when something looks too beautiful to be true, it is too beautiful to be true in most cases. In this case, the system encourages cheating. Not going out to hunt is much safer than going out in the dangerous night. Bats can get lost, are smashed against a tree by a stormy wind, or beaten to the ground by a sudden and fierce rain. Birds of prey sometimes catch bats, and individuals get lost and never find their way home. So it's much safer to never leave the cave, and let your dutiful pals do all the dangerous and heavy work. This enhances your chances of survival. If genetically coded, this behavior can spread very quickly throughout the population. But it's clear that a colony with a majority of these individuals can never survive. Both the idle and hard-working individuals will go down, because of the behavior of the cheaters. And this is one of the rare exceptions where group selection is the only plausible explanation for what happened. So something had to be done to prevent the bats from going extinct. The evolutionary system came up with a solution. It devised a new structure to prevent these cheatings. Vampires developed larger and more complex brains in comparison to other bat species. This for two new reasons: recognizing other bats as individuals, and for having a strong memory, being able to remember to whom you gave blood and from whom you received it and in what amounts. They became skillful bookkeepers. This way, deception could be prevented. Humans are hunters too. Humans share meat too. Cheating no doubt occurred in human groups too. So probably for the same reasons as vampires, humans developed big brains to recognize each other as individuals and keeping records of the help given and the help received. And once these big brains were a fact, their development originated an entire dynamic of its own, ending up with the most spectacular and unbelievable feats we now see among our own species. Having a strong feeling of justice is one of them. A special video in this series is dedicated to this most interesting topic. Cooperation, helping and deceit has long been a subject of interest to economists, philosophers and social scientists. One of the oldest and most interesting phenomena in this field is the tragedy of the commons, first described by economists. Farmers in the Middle Ages had grounds of their own, and they could use common grounds, forests, swamps and heathland areas, to graze their cattle. Everyone could use it freely, no one owned it, it belonged to the community. In time, some unwritten laws or rules of conduct originated on how to behave oneself. Rules as, for example, it is best to give grass time to grow before having your cattle graze on it. If the grass is only half grown, the yields of the commons are smaller in comparison to waiting a few weeks until the grass has reached its full volume. So it would be wise for everyone to wait until this moment. But what if one person breaks the rule? His gain by doing so is enormously. His cattle will grow fat much sooner, and he can make a good profit out of doing so. But you can imagine other farmers are not happy with this, and their inclination to break the rule too is very tempting. And if 2 or 3 farmers broke the unwritten law, number 4 and 5 will follow soon. And in a short period of time, everyone is having his cattle grazing the commons long before the optimal moment. Result? The total yields of the fields is only a fraction of what it could be. if everyone behaved wisely and sensibly. It happened in the Middle Ages, but we can detect these phenomena everywhere. Commercial fishing boats catching fish too young and too small. Why? If you don't do it, your competitor will, and then he has got a little, but you end up with nothing. Throwing garbage away, if you would be the only person who did this, it would hardly be a problem. But if everyone does, we will soon be living in a complete mess. The broken window theory of policing is based on just this principle. Make sure no one can make the first bad step, and the community will be much cleaner and safer in comparison to permitting small misdemeanors. Driving a car that pollutes the air, you know it's no good for our climate, but your little contribution to the total of the climate problem is minuscule, especially compared to your big enjoyment of being mobile. But if everyone thinks this way, well, I don't have to tell you the consequences. Why are tree trunks that long? It may seem a funny question, but the answer has everything to do with the tragedy of the commons. Building up a long tree trunk costs a lot of resources. Resources trees could have better used for making roots to acquire more nutrients and water, leaves to transform sunlight into sugar, and seeds to procreate. Big trunks in itself are of no use. But why did they originate in the first place? The answer is, long trees are the result of an arms race. Trees most certainly started as small shrubs or bushes. But if one mutant had a bit longer trunk than the other ones, it gave him a huge advantage, because he can catch a lot of sunlight in expense of his smaller neighbors. Therefore, he has much more offspring, and within a few generations all trees are longer than the ones before. But again, the same process starts. Again, one tree grows a little bit bigger, etc., etc. You know the story. An arms race to the bottom, in this case into the heights. You see, the phenomena of the tragedy of the commons is everywhere, in economics, in social systems and in nature. It's one of those elementary evolutionary principles that shape our world. Social scientists developed all kinds of simulations to study these processes in controlled circumstances. One of these is the wolf's dilemma. Suppose you participate in this experiment. It goes like this. You are sitting in a room with a dozen or so other participants. You cannot talk to each other because there are fences between the people. In front of you there's a red button on your desk. The rule of the game is simple. Do not push the red button. If everyone will succeed in this for 5 minutes, everyone will get $100. But if one of the participants pushes, he will receive $10 and all the others will receive nothing. What will happen? The most rational decision is, of course, not to push the red button. But time and time again we will see that one of the participants cannot resist the temptation and pushes the button, thinking, if someone else presses the button, I will have got nothing. If I press, I'm sure of $10. So pressing is the sure option. If someone else is thinking the same as I do, he will push too. So I'll better push it right away, before he does so, and I will end up with nothing. Even worse, if you repeat this game a number of times, everyone will run for the button as soon as the game starts. So yields are only a tiny fraction of what could have been. The public good dilemma is a variation on this experiment. In this game, everyone can put as much money in a common jar as he wants to. Other people do too, but no one knows what the others have contributed. When everyone has given his donation, the experiment doubles the total amount and shares it equally between all participants. Rational strategy for everyone to donate as much money as possible. What is actually going to happen? People are downsizing their individual contributions, hoping to gain from the doubling caused by other people. And just as with the vampires, this will destroy the common cause. In the end, participants end up with only a tiny fraction of the money they could have earned. Free riders emerge everywhere, and they pervert the systems and spoil it for the productive participants. But there are also positive examples of these very same principles. One is described by historian Tony Ashworth. He called it the live and let live systems. The trenches of World War I were hell, and soldiers soon saw the absurdity of it, trying to kill men at the other side of the trenches, people feeling as miserable as you did, and they were equally convinced of the absurdity of it all. Going to talk with each other was of course not possible, and would be punished severely by the officers. But the soldiers discovered a way to communicate on a whole different level, and that is to misshoot as ostentatiously as possible, not aiming at the enemy, but shooting far above their heads. This was soon picked up by the soldiers on the other side. They started shooting in the air too, so the message had come across. Officers didn't notice at first. The daily quota of ammunition were shot, and how many casualties the enemy had was difficult to detect. When the fraud was eventually demasked, severe punishment had no effect. Being shot by the enemy or by your own officer didn't matter very much. The only way to destroy these live and let live systems was by relocating soldiers very often. These systems take time to develop. Trust had to be built up first, and that is no easy feat. However, there are examples known of soldiers having informal ceasefires to celebrate Christmas with their enemies and fighting on the next day. How absurd man can be. The most famous simulation of cooperation and deceit is known as the prisoner dilemma game, invented by Morgenstern and von Neumann. In this hypothetical situation, two robbers are arrested. The police can easily prove the robbery, but unclear is who murdered the shop owner. To discover this, the police tries to pit the two prisoners against each other. They are locked in two prison cells and cannot communicate with each other. If they cooperate with the police, they get reduced sentences. But of course, each prisoner doesn't know if his mate will be loyal to him or betray you for his own advantage. The situation goes like this. If they both keep their mouths shut, so if they cooperate with their friend, both end up with 5 years in jail for the robbery. If one of them betrays his friend, 3 years are cut off his sentence, and he will go 5 minus 3, so only 2 years to jail. His mate, however, pays heavily for this. He gets a sentence of 5 years for the robbery, plus 10 years for the murdering, so a total of 15 years. If they both betray each other, both will go 15 minus 3 is 12 years to jail. What will they do? Experiments show the same results as in the experiments previously mentioned. Cooperation would be the most rational strategy for the suspects, but when one starts cheating, the other will soon copy this behavior, and the total amount of punishment they receive is much larger than in case they would care about each other. A very interesting extra dimension to this line of research was added by Robert Axelrod. He asked computer programmers to write programs designed to follow a certain strategy in the prisoner dilemma game. He pitted these programs against each other in a tournament, doubling after each round the winners and removing the losers, so simulating biological evolution. What will be the direction evolution chooses? What will this competition reveal to us? Let's have a final look at these most intriguing experiments. Axelrod's first discovery, being nice is nice, but is not going to win you the game. Two nice programs, that means choosing always for the rational constructive option, get along together well, but when a nice program meets a cheating program, it's abused to its death. Pure cheat programs neither do that well. When faced with another cheat program, they end up in an arms race to the bottom, just as we have seen with the Wolf's Dilemma, the Common Goods game and the Tragedy of the Commons. Another option was a random chooser, sometimes being nice and sometimes cheating. Again, this wasn't the final solution to the problem of cooperation mixed up with egoism. The first rounds of experiments, however, showed one superior program, called titfortat. This program starts nice, but after the first round it copies the move of his opponent. When it meets a nice or another tit-for-tat program, it operates in a constructive fashion and both players score a lot of points. When it meets a cheater, it will not let itself be abused, but reacts with retaliation, thus limiting the damage. One of the more surprising findings of this line of research is that the shadow of cooperation has to be long. What do we mean by that? In case of an infinite or unknown number of rounds, it is always rational to start nice and stay nice as long as possible. In a one-round game, however, it is not. Here the best strategy is, go for your own selfish, immediate interest. If the other does so too, the damage is limited. If the other is nice, it gains you some extra points. So cheating on someone you will never meet again is quite rational. But if you meet him more than once, the cards are completely different. And then cooperation is the most rational choice. But what on a fixed number of games? Let's say 10. Then it turns out, and we are still talking about these computer simulations, to play 9 games cooperative but be an asshole on the last one. Why? It gains you some extra point, but there's no risk of retribution, because there will follow no new rounds anymore. Playing multiple series, a rational program knows this, so the game is reduced to 9 open rounds and 1 predetermined one. So it's in fact a game of 9 rounds. And this will mean, as you might have guessed, that the 9th round is a fixed one, namely the one in which it's best to cheat. Knowing this, only up to the 8th game the choices are open. In fact, a game with a fixed number of interactions is the same as a game with only one interaction, and then the selfish choice is the best choice. Joris Luijendijk, a Dutch journalist and anthropologist, wrote a book about the culture of Wall Street and the City of London. In this highly competitive environment, banks use rank and yank systems. This means they make a rank order of their employees every year. The top 15% is overloaded with huge amounts of money and bonuses. The lower 15% is fired, yanked. Someone in this bottom 15% is inclined to think he has nothing to lose. He will know the cooperation will probably end soon. And we saw this encourages short-sighted egoism as the most rational strategy. The best option for such an employee is to take extraordinary dangerous risks. If it pays out bad luck for the bank. If it works out well, good for the bank, and the employee can lift himself out of the lowest 15% and probably have a nice future with his employer. Nick Leeson was such a guy, with facing the risk of being yanked, but the risk he took with the $1 billion of the Barings Bank was so enormously that this losing meant in fact the end of the Barings Bank. Evolutionary psychologists could have told the management of the Barings Bank how stupid their policy actually was. But would he have listened? Maybe, maybe not. Taking this line of reasoning a few steps further, both Nick Leeson and a normal, middle-of-the-road employee of the bank are doing the very same thing, following a strategy that benefits their own self-interest the best. Long-time cooperation is good for both partners. Short-time cooperation benefits in most cases only one of them, as we have seen when we talked about the pestilence bacteria, rabies, syphilis, and the bacteria in our own guts. To put it bluntly, the only difference between a bank robber and a bank employee is their number of interactions. Think about that for a while. And there are other surprising points of insight. I told you that nice programs don't do very well. They are eliminated by cheaters. The winners, up to this point, are the tit-for-tatters. When simulated evolution conditions, they will after a number of rounds of the tournament have taken over all of the population. When you enter at that moment new nice programs into the populations, like entering an invasive new species in a given ecosystem, like rabbits in Australia, they will take over half the population after a number of generations. Why? In their behavior you cannot, under these circumstances, make a difference between nice and tit-for-tat programs. They both act the same, nice, so they are both equally effective. The only difference is that the tit-for-tat program has the potential to be not nice, an option a real nice program is missing. But this is never used in the environment just described. Some programs need trailblazers before they can flourish. Translated to our modern society, some belief systems can flourish in the modern world because other systems have created a beneficial environment for them. An example is pacifism. This thrives well in our modern, prosperous and safe circumstances in the Western world. But these circumstances have only been achieved by systems just the opposite of it. If we hadn't fought that fiercely in World War II, these systems had no ecosystems to survive in. But the story is not over yet. In the end, a program was designed outsmarting tit for tat. Carl Sigmund was the inventor of it, and he called it Pavlov. It acted just like tit for tat, but at random moments it could switch and act like a cheater. If confronted with another tit for tat or Pavlov program, his opponent would react with vengeance too, and Pavlov was then programmed to turn the other cheek. It did what the pure tit for tat program couldn't do: react on animosity with friendliness. This way it lured the other back into niceness, which was of course in its best self-interest too. However, if his opponent didn't react to his egoism, for example when it met a nice-only program, it continued its exploitative behavior and abused the other to its own advantage. In other words, it had a detection system to find out about its opponents and act accordingly with its own interest in mind. If you meet strong and cunning systems, be friendly. If you meet naive or weak ones, exploit them. Sounds cynical, but it's that simple. Notice that this is a common tactic in international policies. Powerful countries act nice to each other, playing it decently, because they know doing otherwise would harm them in the long run. But they pursue their own self-interest in an unforgiving hard way when your opponents or partners are weak, easy to exploit, and unable to take revenge. This is an important reason not to cut too drastically on defense budgets. To end this video, let's recap and look ahead. We saw the importance of cooperation. A very important point is that trade and cooperation are never zero-sum games. Clever cooperation can be good for all parties involved. Wealth is something that can grow by dividing it, not by giving it away out of charity, but by establishing productive relationships based on specialization and division of labor. This is also a strong force for peace, as Thomas Friedman showed us. The EU is another demonstration of this. Germany and France had a long history of wars. Every 30 to 50 years they drew arms against each other. This destructive pattern ended with the establishment of the European Union, the EU. So Brexit wasn't a very smart idea. And I hope there will never be a Nexit. I'm Dutch. This having said, the EU needs reforming. It's too bureaucratic, there's not enough democracy in it, and is going much too fast. But to end on a high note, here's John Donne, a British poet of some hundreds of years ago. He wrote, "No man is an island entire of itself. Every man is a piece of the continent, a part of the main." Wise words to end with. Thank you for watching this video. In our next video, we again dive into some very interesting subjects. How did man evolve? Why are we hairless? Are we natural carnivores, or do we tend to veganism? Why do we sweat and cry salt? What can explain our big brains, our superior intelligence, and our astonishing ability to cooperate and our uses of languages? If you want to know, stay tuned. If you like this video, please share it. And don't forget to like and subscribe.